Right, so in this video, we're going to be learning, we're going to be learning how to graph cosecant, which is the reciprocal of sine. Reciprocal. This is the reciprocal of sine, right? So remember, one thing about reciprocals, whenever we're evaluating for sine, for example, of pi, we're going to see that this equals 0, and then the reciprocal would equal 1 over 0, which will be undefined. So this is the reason why we put the asymptotes. Let's put as at x-intercepts, because your y, 0. Right? Copy this down. But now let's actually get into an example. Make sure you guys copy this down. So, let's say we're graphing. Remember, this graphing cosecant and sine is basically the same thing as we did for cosine and secant. But let's say we have y equals 2. Let's do. Remember, I said previously an example. I think I did cosec or something. Like this is okay, right? Because it's cosecant. That's how you spell it. But usually the abbreviation for it goes like this whenever you're dealing with the function. So you have ck, as I like to remember, equals, let's say, let's do x minus pi plus 1, right? Remember the standard form. Y equals a dx opposite, right? OC. Let's do this is the standard form, and this is what we have. Right? So amplitude that would equal absolute value of 1, which equals 1, period. We would have this would equal 2 pi divided by our b is also 1, so it would equal 2 pi. X scale. Remember, you guys have to see the difference between secant, cosecant with cotangent and tangent, because it changes a little bit, as I previously mentioned, as you previously saw it. Equals 2 pi fourths, cancels out, equals pi halves. Right, remember, algebra simplification, very important when dealing with trigonometry, especially trigonometric functions. So next, with a phase shift, let's just do the and. The starting points, any point is useless, but you usually do it to see where you're at and to see if you have made any mistakes during your working out. So we have x minus pi equals 0. So we add pi, cancels out, add pi, so x equals pi. This is our starting point. And finally, we have our lovely vertical translation, which equals 1. Finally have it. Keeping these important points, let's actually graph this. I don't think we're going to the negative direction. Last video showed you what it would look like. Same thing. Sometimes you need to, right? If your starting point is at a negative number, but, oh, sorry, here, right? But in this case, it isn't. So I always like to start, let's do this more straight. I always like to start at this, our phase shift, right? This is the ideal. This is pi. We know our amplitude is 1, and it goes down to -1, right? And then our x scale is pi halves, so we know that pi plus pi halves would equal 3 halves, right? And if we add that to pi halves, you have 4 pi halves. Add another pi halves, you have 5 pi halves. Add another pi halves, you have 6 pi halves. And of course, you can simplify these two, but I'm not doing it in terms of here right now, because it's not really important, but it's always good to simplify this and this in the exam, since you'll have the chance to. But that's not my focus in these videos. My focus is to just teach you guys how to graph this, for that we can translate it on the computer. So remember, I told you forget about cosecant. Remember, convert this identity into sine as you're graphing it, right? So we just normally graph sine. But remember, we also have a d now. But first of all, just graph it normally, right? So let's put this one a little bit up. It's 2 down. Okay, so we start our phase shift, right? We start here, and then we go to its max, go to its intercept, we go back to its min. Let me put that negative one also a little bit more down. Go down to -1 and back to our intercept, right? All of these here are 4 major points, remember? Right, so this is a point for here, here for here, here for here, here for here, and here for here, right? But this is definitely not all that we have, especially because we're shifting all of this up 1, right? So what we say is that we create our imaginary, and this is probably we create our imaginary new y-axis, x-axis, right? Which will now be here. We know this x-intercept is shifting 1 up. This intercept shifting 1 up. This intercept shifting 1 up. This one shifting 1 up. And this one also shifting 1 up. So now this will be here. Right? And now what you have to do is connect these. Oops. Make sure you have a ruler if you want during exam. And then our minimum is now here. And that. This is how our graph looked with the V, with that VT. New graph. This would be our new graph, right? So let me just delete the old one. Let's see if we can do it without messing up. Oh no, this is, oh, sorry. This is the one we just did. Need to delete this one. Remember, this was 4 pi halves, and this was 6 pi halves. This is a new one, but remember now, we're not graphing sine, we're graphing cosecant. So remember, at our intercept, whatever asymptote, intercept, asymptote, intercept, asymptote, and what we do, this will be our vertex there. We create our mini parabolas, right, at our minimums, and this is a max vertex point, right? You can think of as a minimum vertex point, a max vertex point, right? And these are our little parabolas, mini parabolas. And then we delete, you leave your asymptotes, right? For example, you delete your sine because that's not what you want. You just want the mini parabolas and the asymptotes. You can leave the vertex there if you want, right? And that's your final answer. But then, let me just show you some technology, because then in our next videos, we're only going to be dealing with technology. So if we jump here, you can see, let's say, let me show you the difference between secant, the graph we previously did on our last video. You can still see no sign of cosine, right? We can see it's approaching some line, probably this line. It's an asymptote. It's not going to show it on a graphical calculator, but we can see our mini parabolas. And now if we're dealing with our current graph, which is cosecant of x, it changes a bit. You still have your mini parabolas. You can still tell there's an asymptote, but no sine graph there. That's why we erase it. But you can see it's different because, first of all, when graphing secant, we were parent graphing cosine. And now, for cosecant, we were pair graphing sine. So, thank you all. Guilherme de Castro.